Okay, so my name is Francis, and this is about the Marine Arctic Ecosystem Study, MARES, which many of you have heard about before. And so I'm going to skip over the general stuff very quickly. And I wanted to give an update on some of the analysis we've started on the mooring data that were out for 2 years. And so this is the results or preliminary results from the first year. So this is fall 2016 to the fall of 2017. And I'm just kind of the talking head really here. I'm the lead PI for this program, which is funded by BOEM through NOP with several other partners. But you can see there's a big team of people who contribute to this particular portion I'll talk about today, and there's more people for other parts of the components that I'll talk about in a minute. So the overall goal for MARES, for those of you who hadn't heard about this, is just basically to understand the interrelationship of biophysical and chemical drivers that influence kind of the system in the Eastern Beaufort Sea, and I'll show you the map here in a minute. The biophysical chemical component of the program has kind of 3 components. It had a mooring with moving platform, so that was a glider deployment. It had a benthic sampling component and has this mooring component. We also had a biological component that dealt with marine mammals, and this was CTD fluorometer tags on ice seals, and we reported on this previously. So I'm not going to go over this. Also, the glider work was led by Dong Lai Gong from VIMS, and I spoke about this previously as well. And here's a reminder of that. And then the sediment work was led by Roger Harvey and Pam Newbert from a chemical and biological piece, and we reported in the past on that as well. So today I want to really just give you some highlights here, the thing that's in red, which has to do with this particular task order. And this is really a good collaboration with all the institutions you see in the bottom there, including Fish, Winds, and Oceans, because we did this work from the Laurier, and we will be doing bringing some of the data sets together. Of course, the DFO, ArcticNet, and others had in the region for some time before. Okay, so this is where we are. We're right across the border in Canada, in the Mackenzie, off the Mackenzie Delta, in the Mackenzie Trough. You can see the moorings here. There's Herschel Island, Alaska on this side, and here's the trough, and there's several other moorings in this region which are not shown here, which are going to expand what we're doing both on this side here, further out, and then in this region over here that's been deployed by DFO, and of course several of you have worked on the Alaskan side here as well. So the idea here is to kind of capture the plume as it comes out and figure out where it's going, what it's doing, and how the water's being modified, but also have a deployment that goes year-round to figure out what some of the basin shelf interactions are and what some of the drivers might be. So we have the moorings here. The closest mooring here is like in 15 meters of water. This one here sits in about 350 meters of water, and then there's another one here that sits about 700. The cross-shelf array of these moorings has biophysical chemical sensors, and here is them. So they vary from the sea spider there on the right in very shallow water to very deep moorings, kind of general setup, but with a couple of cool things like some of the MMP profilers, like is shown here, and also a couple of really cool microcasts that deal with the ice, that are a weak link, that when the ice comes over, they can be knocked off, but the rest is I can still be recording. And that was kind of a little bit of a trial, given where this is, but actually worked super well. So I'll show you some, but not all, the highlights that have to do with some of these bullets. Okay, so here's kind of cross-shelf. This is kind of where we are, but we can get into that more if you want. Okay, so I'm going to go by kind of section. So the physical oceanography highlights here. We have on the top is the ice concentration. So you see this graph. I was going to see this graph a couple times. So we deployed in early November, and ice built up fairly quickly after that. You can see there was a good ice cover between January, but mostly really good from February to April, fast ice. It was a really strange event in April I'll get back to a little bit, and then it kind of went away in June. On the bottom is the currents, and you can kind of see that the main, the subsurface shelf break current here is somewhere between 40 and 120 meters, probably with kind of the maximum current around 70 meters or so. We kind of see this in this profile as well. You can see somehow in some places it kind of goes pretty limb or reverses in some instances when the ice is there, but it's variable, but mostly present. So I'll highlight this mid-April thing here as I go throughout, not because it's the only feature, but it's a really cool, consistent feature. It's one of the things we're investigating further as we go along. And one of the reasons that I want to go into this April piece is this graphic here. So we have satellite pictures here on the top show sea ice from early April, so April 4th, 2017 through May 17, not all the days, but kind of snapshots here. And here are the red dots that maybe you can see. This is where the moorings are. Mind you, they're under the ice, right? And then the wind, so this is the ice draft here, and I'll show you wind later, but the wind shifted and opened this big lead. So there was still ice. So one of our moorings here was still under the ice, this one here, and probably M1 as well. And these other ones got opened up. And so there's landfast ice here, and this lead opened up quite substantially, quite rapidly too. In a couple of days, you can see here, and it was open for maybe 10, maybe a little bit longer, actually probably 2 weeks or so. The wind shifted again, and it closed back up. Okay, so those things probably happen on a regular basis, but we're never out there when this happened, nor have we had any instrumentation, year-round instrumentation that's measuring these biophysical and chemical parameters throughout. So it was interesting for us to kind of then see what happens in the water as this happens, as these changes on the surface, mostly wind-driven, are going on. And then we also have this kind of interesting ice draft changes that we're still digging into a little bit more. Okay, so I showed you the ice graph already on the top. So this comes from those profilers, and this is at M2. So this sits in about 150 meters of water, this mooring does. It's looking upwards for the ice, and here you have some of the ice velocities. You can see it's pretty variable, moves in different directions, moves south, moves east, moves west, and then really once the ice kind of sets in, obviously, there's not a lot of movement. There's still a little bit every now and again. It moves as one big thing, but obviously the less open space there is, the less movement there is. And then movement starts again here when this ice breaks up and then goes dormant for a little while longer. So this physical driver, wind and ice driver, leaves the signature in the temperature and the salinity as one might expect. So we have I'm showing you the ice concentration again here on the top. And, with the ice there, you'd obviously get newly ventilated winter water, which is in water that's below 1.7 Celsius. So the temperatures are the colors, and then there's salinity shown here in these contours. And what we see in mid-April, when this ice event happens and it breaks up, is we get Atlantic water. So this is being upwelled water. So warmer, more saline water is being upwelled. Here you can see this is a 27 contour. It's kind of hard to see, but it kind of comes up and then it goes away and it comes back in October. So this is from M2. So that's happening there, and we'll explore kind of what happens to some of the other parameters during that period of time. And one of them here is we have this upwelling event. It's shown, and I saw 3 periods here. We'll see here. Okay, so there's a whole bunch of upwelling events throughout the year. And so obviously, like the colder nutrient-rich waters are coming up to the surface. There is a really nice one that's shown here in June. So this is the overall time series here, the whole year. And you can see there is this one in April, which we just talked about, which we saw from that Atlantic water. And then there's a really big one here in June. And it's kind of hard to see here, but when we zoom in, so this is now June 21st to beginning of July, you can see the velocity of the water velocity is much, much stronger. We get this upwelling event and with currents up to 105 centimeters per second, so just a meter per second. And it's and you can see other oscillations in there in the data as well. Okay, so that's a snapshot of the physics. So what happened to the chemistry at the same time? So we have here the whole year shown. So from November to October the following year, so 16 to 17. On the top in blue is the salinity, and then in orange and red are nitrates. Both in M1, so this is the further inshore, it's on the shelf, and this is kind of in deeper water, about 150 meters of water. And then we see that during the time of low productivity, so in the fall, like late in the fall, and then into early June, the nitrogen concentration are kind of behaving. So they're kind of generally following salinity, what you might expect. And then when the ice breaks up, there's a plume, which I'll show you in a minute, and then we see this nice decrease in nitrates. So the story sort of is somewhat matching. On the top there, so when the upwelling events happen, the nitrate concentration is kind of not really happy with the salinity afterwards, and so you get a disconnect here. We see it here, and then this goes completely wacko here as well. And so these upwelling events are creating a disconnect in some of the physical and chemical parameters as they do during kind of like low-laying situations. So it's not a huge surprise, but it's nice to see the signal making it through the system. So if you remember, we had PCO2 sensors out as well on M1 here, and so sitting at about 36 meters of water. So this is a bit further inshore, and it's something that was covered by ice still, even during this event, but the water was influenced nonetheless. So this upwelling event seems to have made it further to the inshore, and we're still looking at some of the details. But so you have the SAMI sensors here, so temperatures on the bottom. We have the PCO2 readings, and they start pretty high at 400, and you can see they kind of fluctuate between 400 and 600, and then something weird happened here. There's this big jump in April, and then it stays high, and it stays between 600 and 800, and even goes up here. So we're still figuring out exactly what happened. Our initial reading of this is that something happened with the sensor. Maybe when the ice was moving around, maybe something got knocked off, because at the very end, when we sampled, we collected, like you always do for PCO2, collect a discrete water sample for PCO2 measurement. You can see that that's this one here at 400, whereas the sensor was up here at 800. But so maybe something weird is going on. Maybe the sensor, something happened to the sensor, but all these other things, the salinity here did a jump as well, and these numbers here are at different depths. So we have a whole bunch of different sensors at different depths, and so they also made this weird jump at the same time, and then stayed kind of high. So we first thought, yeah, this must be a mistake, and maybe the sensor went weird. But then as we're doing all the other things I just showed you and some other things that are to follow, that this big event happened in April, maybe what some of the physics are driving, maybe that's not weird. Maybe the water that came up is just really high. We're not sure yet. There was also PCO2 sensors at M2 at the same depth, so this is a little bit further. And here, again, if you look at the black line, we started lower, further offshore, at about 300, and there was almost constant decrease with some jumps here in June and in the fall. And these coincide with some of the blooms that we see later on, but didn't have this big jump here like this other one did. All right, so foreshadowed some of the biology already. So we have fluorometers on there. And what we see nice is this time series at M2 from the MMP, and some nice signals for a spring bloom here in June, mid-June, July. You can see here actually goes then fairly deep, but nice and strong, and then a fall bloom as well that starts in late September and makes it, well, actually, yeah, second half of September into early October. So, and then these are the two things that we see in that those two spikes in the PCO2 as well. You'll note that if you look at this entire time series, there's a big hole of almost no fluorescence whatsoever right in mid-April. So of course you would think there wouldn't be much there, and in the winter, and there isn't, but there is a little bit of stuff in the water. But then it just kind of clears out for a couple of weeks, right at the same time that all the other weird stuff is happening in mid-April. So we also had ADCPs, and so we're looking at so Karen Ashton was looking at the backscatter and see, and we had AZFPs as well, and so we could compare and see what those doing. So we're looking at the taking the smooth absolute backscatter as an indication of mesozooplankton, and we actually managed to validate that these seems to be true signals. So it's nice because we can see, so this is again the entire time series. We can see here the bloom that starts at the same time, so where we have the fluorescence bloom, we get more mesozooplankton here, and it kind of is really present all the way till about November. And then there's backscatter in the water column almost the entire time, with the sort of exception of that period. That's like the least amount of backscatter, again at the same amount of time. So this is at M1 and at M2, and here's the depth here. This is so shallow. This is the upper 35 meters of water. So we also had these at M2, and we did something similar. So here in blue is the backscatter anomaly. So we see high periods of time in the summer. So here, June, July, and then for the fall bloom, and then it kind of goes away in the winter. It spikes again in January, not really sure why. The temperature seems to have gone up there for a little bit, and that seems to go along. And then it takes a nosedive in mid-April at the same time where the temperature shoots up when the ice went away there, and the anomaly just goes away. So that follows some of the other stuff, and you see the same signal with the salinity jump as well. This goes up and this goes down. So this Atlantic water that's upwelling to the shelf is having a much bigger impact, I think, than we may have realized before. And since we're after drivers, this is kind of cool information. The other cool thing that comes from the acoustic backscatters is that we actually have nice signals of diel vertical migration of some of these mesozooplankton. So we'll show you kind of 3 quick snapshots. So this is March. You can see nice migration. So there's presence on the surface. But you see here this green spot, so this is night and day, and they go down all the way to about 80 meters. So during that period of time, that's where the migration seems to, or the depth variation seems to go from surface to 80 meters. In April, it seems to go in some places even below here, so it's getting more pronounced, not quite as clean, but you're getting some light here in mid-April, remember? Because the ice went away and the water is getting a little bit warmer. And then once we get into June and the ice is gone, basically the migration, the vertical migration patterns are kind of gone. You kind of get subsurface maxima here every now and, well, not maxima, we get subsurface signals here every now and again, but really it's in the top 20 meters. So it's cool. This is all from the backscatter. So we also had AZFPs. And we were looking for signals in the acoustic signals for copepods and fish. And so this first one here is copepods. We can see it. So this is sitting in about 50 meters of water. And And we can see that they're present in the upper water column from October to April here. So this is when we deployed. So we're looking for yellow, warmer colors. So pretty good. Something weird, April, it went away. And then when we have the phytoplankton blooms here, June, July, and then into the September, the copepods are present in at least the top 50 meters. We can convert some of these signals into biomass, if you like, here, which is kind of this index to tell us where kind of the main, when most of them are there, and we can see kind of a spike here, weirdly enough, in March, but then the majority of them here seem to go consistently there a little bit later on during this period. And again, this hole here. So the same type of data, but looking at acoustic signals for what we think are juvenile cod. Remember, there's no sampling here, right? So this is from acoustic signatures. So we believe this is juvenile cod. They were present near the surface from July to October, really gone in the winter, with a peak in August, right? Which that would make sense because they're taking advantage of that spring bloom that we saw earlier. And lo and behold, there's a hole. And then we have also what we think are adult Arctic cod. So this is now sitting at M3. So M3 is at 270 meters. So look at the depth here. So this is the bottom, and you can see here that the Arctic cod in the winter. The most of the biomass is in December. So right here. Not really present the rest of the year at this depth or this location on the shelf. Mind you, this is fairly far offshore already. And subsurface. So they seem to be hanging around in, below 200 meters of water in this particular area between October and February. Maybe a little bit into March. And then finally, on our whirlwind tour here, we have some marine mammal detection. So Kate Stafford had a PAM out on M2, and so we haven't done a lot of detailed analysis. We're just basically listening. So this is, did we hear anything or not? This is not how many calls or whatever. This is by week for the entire time series. And basically, you can see that bearded seals are heard pretty much the entire time, with the exception of sometime in July and August. And beluga whales are there in the winter. Bowhead whales are there. Actually, sorry, in the fall. So this is May to September. Same for bowheads, and then ring seals are kind of sprinkled all throughout. Okay, so we're looking into, yeah, almost done. 2 more slides.
What moorings do those recordings represent? The marine mammal detections slide.
I believe it's on M3, I want to say.
Okay.
M2 or M3, I have to go back and check.
Okay,
we had 2 of them out the first year, and we had 1 of them out for the second year. So I can't remember which ones these come from. M2 or M3. Yeah. So, okay, so we have this, I mean, there's lots of cool things that we're diving into in more detail, and we're adding our second year of data now, but, just the first kind of cool highlight story is this mid-April thing. And if we put it all together, and this is one of the really cool things, like many of you know, when you have this interdisciplinary work, rather than just looking at one parameter isolated, and of course, if you're looking through the entire year, so you have a bit more context, we can look at some of the physics, some of the broader oceanography, and we see this upwelling at M2. So remember, M2 is this dot right here. The chemistry all increased. Nitrins went up, temperature went up, salinity went up, PCO2 went up at the same time period. And all the biology went down. The fluorescence, mesozooplankton, copepods, and juvenile cod all went down at the same time as well. So cool things, thinking about mechanism and drivers. And we want to go back and look at the broader record and see how often these events occur. And then we want to get together with some of our colleagues to have a broader geographical space, maybe to the east and to the west, and to see if some of these same signals and how far-reaching some of these events are. And do they last long? I mean, this is these things where there's a pulse in the system just for a couple of weeks, or are there repercussions for what happens later in the summer? And we don't know, because we only have 2 years and we haven't looked at the second year yet, but there's certainly lots of interesting things to pursue. So our next step then are looking at year 2, and that was the moorings were pulled out of the water, and so the field component of MARES ended in November, last November. And so we're doing the QA/QC on the data and the preliminary analysis, and then we'll be combining the year 1 and year 2 data across sensors and across moorings. And then we'll also come back in and bring the glider data in, because if you recall, the glider data, the glider track here is this line here, and it did this multiple times. And so it includes the mooring line when it was put in, and this was done in August and September. So we want to bring those data sets in, because there's much finer scale sampling that happened. The sediment samples in terms of carbon export and myofauna that we have from this region are also kind of the only data so far like it, and they happen right underneath the moorings. And unfortunately, we only have it from the beginning when the deployment, and we never got a chance to go back and sample again so that we could see the end result of all these processes we just described. But we'll do what we can. And then we also have collaborators. These are some of the Canadian moorings here in green that provide a longer time series. Some of them have been out there for a long time, but also a bigger geographic scale. And then, of course, we have the Aeon mooring over here, and more things to the west of that. And so we're planning for a synthesis meeting for the MARES data in probably October or November, or in February next year. And it's a little bit dependent on when we can get our last mooring out. I said all the moorings were pulled, but M1 here got stuck. If you recall, there was a really weird ice situation last fall where heavy sea ice was pushed into the shore, and it created havoc for many of our programs. I know many of you on the phone, the same thing happened, and many moorings stayed there and hopefully are still there, and we're going to retrieve them this year. And depending a little bit on the timing of when we retrieve them, it'll drive when we want to have the synthesis meeting, both for the MARES PIs, but also for people that basically have generally worked in this region to kind of put together a synthesis of some of the mechanisms for this particular area of the Beaufort Sea. And those are the highlights, more to come.
Thank you, Francis. Where are you planning to have the synthesis meeting? Is there a sense already?
Yeah, well, I have a sense in the, but it's a little bit. I'm trying to figure out what the best logistic location is for all the people going to attend to make it cheapest and most efficient in terms of travel. So it's probably not going to be Alaska for that reason. If you saw all the collaborators, they're all over Canada and the U.S. So we're thinking likely Chicago or Seattle.
Okay.
But we're still open to other suggestions. We don't have a full list of participants yet, so it's a little bit dependent on that.
Thank you. Questions for Francis, please.
All right, thank you.
I have a quick question regarding the sea ice data you mentioned earlier in your presentation.
Yeah.
Is that data already available in the AU's website, and what can you describe the data?
Yeah, so yeah, that's all the ice data. So all the year 1 data is on the workspace. And this will be the ice profilers, and so there'll be a subfolder there on the year 1 mooring, Guillermo, and then if you go to the ice profiler data, it'll all be there.
Okay, thanks.
So this is also for those of you who know, but the MARES program is run by a series of task orders, This one here is task score of 5, and the final report that has all the stuff that I just talked about in it, with the exception of the story from mid-April, because we didn't realize it until later, is in the final report, which is currently being reviewed by BOEM, and will be then, once approved, it's going to go up on the website, so people will have the reports for that.
All right. Please let us know when you are you feel comfortable for giving a similar presentation on the second year of data.
Absolutely. I look forward to doing that.
Yeah. Thank you, Francis. Are there any other questions for him?
Guillermo, I just had a quick question. This is Vicki Cornish at the Commission.
Yes, go ahead.
I was just curious about the marine mammal detections and the buoys that were used, because you know that we've heard different accounts of whether we can get vocalizations or detections year-round, and so it was good to see that the buoys are being deployed and are receiving detections year-round. Is that correct? I mean, what is the depth of the buoys that are deployed? Is there more information on that?
Yeah, I can. So this one was, I believe, at about 30 meters or so on the M1 and M2. So this is one would have been sitting at 30, and the other one about 7. The mooring sitting at 30 and 70 meters, and the PAM is about at the same depth, though, at about 30, I think. And they're just regular PAM. So that's a collaboration with Kate Stafford from the University of Washington. Who provided the instruments and is doing the analysis for those vocalizations. But I can get you more I can get you more specifics if you want. If you just want to shoot me an email. Or...
Okay, great. Thank you very much.
Yeah. I'm assuming that's okay, Guillermo, right? To give more details.
Yes. We can talk later, but in principle, yes. I forgot to mention that this Francis presentation is relevant to performance elements 411, 412, and 434. That's actually on the agenda. That was a good segue now to go to Vicki from the Marine Mammal Commission, who is going to mention the Commission's research related updates. Vicki? Thank you.
Guillermo. Thanks, Guillermo. I really appreciate the opportunity to give an update to this group and to listen in. So if folks aren't familiar with the Marine Mammal Commission, we're an independent government agency. We're charged under the Marine Mammal Protection Act to conserve marine mammals and their environment. And as part of these responsibilities, we have a lot of work in Alaska, and especially in the last couple of years, one of the big areas of responsibility is recommending provisions to protect Alaska natives whose subsistence livelihood depends on marine mammals. So we have this longstanding commitment to support co-management and the assessment and management of risks to both marine mammals and to subsistence communities. So I wanted to tell you about one particular project that we've been working on over the last year that's kind of wrapping up. The Marine Mammal Commission has recently conducted a review of marine mammal co-management in Alaska. It was conducted in response to a request by the Indigenous Peoples Council for Marine Mammals, as well as some other Alaska Native organizations back in 2016. And we submitted a grant application to the North Pacific Research Board and were funded in 2017 to conduct the study in 2018. So over the goal of the review was to strengthen co-management relationships in Alaska, because we had heard that those relationships had been deteriorating over recent years, and the Commission had done a previous review, and we had identified a number of recommendations, but many of the recommendations had never been implemented. So we wanted to conduct kind of a follow-on review to get a little bit more in depth and try to focus some of our recommendations on things that could actually be implemented from the findings. So to complete the review, the lead investigator, Jenna Malik, and myself assembled a steering committee comprised of Alaska Native organization representatives, as well as federal agency representatives with direct management responsibility, primarily the National Fisheries Service and Fish and Wildlife Service, to help guide us in the review. And one of the things that they helped us with was to develop a working definition of co-management, which it's not really defined in the Marine Mammal Protection Act. So we wanted to find a definition that was amenable to all the partners and still consistent with the tenets of Section 119 of the Marine Mammal Protection Act. So we have a working definition that guided the project. And then we conducted interviews with 44 individuals at the National Marine Fisheries Service, the Fish and Wildlife Service, and in 7 Alaska Native communities, guided by some case study organizations that that guided where we did the interviews. They were in Nome, on the Aleutian Islands, Barrow, and in other communities, mostly in the Aleutian Islands. So after conducting the interviews, the project findings fell into several different categories, including communication, partner roles and expectations, organizational structure and accountability, leadership training, succession, agency decision-making processes, how Indigenous knowledge is integrated into decision-making, and the future of co-management. So now that we have wrapped up the interviews, we are going back to the communities to report out our findings. Jenna was just in Barrow, is in Barrow this week, and she'll be going to Nome next week. So basically going back to the communities that we interviewed and to let them know about the findings and kind of get some ground truthing on what we heard in the interviews and make sure that the findings are indeed reflective of the community's concerns as well as the agency's concerns and what they think are the priorities for moving forward. So the report's in the final drafting stage, and I hope that it will be available later this spring. The report will be posted on the Commission's website, and we will also be submitting a shortened version of that for publication in a journal. But we're hoping that the recommendations are structured in such a way that they are very directed towards the agencies or the communities or the ANOs to follow up on. So it's very clear kind of what steps can be taken to address some of the findings of the review. So we're hopeful to get that out pretty soon and to get some feedback from the larger Alaska community about our findings. Any questions on that? So our thanks again to the North Pacific Research Board for helping conduct this study with their funding. And then just one other thing. Any questions, Joe? Okay. One other thing is I just wanted to report out that the Commission, consistent with our focus on Alaska, we just recently issued a request for proposals for projects focused on Alaska marine mammals and subsistence use, sustainable subsistence use. And the title of that RFP was Impacts of a Changing Ocean on Marine Mammals of Importance to Alaska Communities. And the Commission doesn't necessarily have a lot of money, as Guillermo knows very well. We have very small investments that we can make, but we tried to make them in a way that jumpstart projects that otherwise wouldn't be able to be conducted, or maybe, and we fund a lot of things internationally. But one of the requirements of this RFP was that the applicants needed to have needed to demonstrate meaningful engagement with Alaska Native communities in the development of the proposal and in the implementation of the proposal, with preference given to projects that include Indigenous knowledge and provisions for data sharing with the Alaska Ocean Observing System and other data portals. So the RFP deadline was extended because of the government shutdown. Scientific editors are currently reviewing the proposals, as well as myself, and we hope to get back to the applicants by April 15th to let them know whether a full proposal will be invited. And then hopefully our notifications about the successful applicants will be done by the end of July. So more information about that request for proposals, it's still up on our commission website, as well as all those deadlines. And we hope to get some good, strong proposals and have work be done that otherwise wouldn't be able to be done. And the involvement of the Alaska Native community is a very important component of this proposal process. So that's it.
Any other questions for Vicky?
Hey, Vicky, this is Francis. On the report on the co-management group, you said it's going to be in spring. You said this at some point?
Yes, that's right. We have a preliminary kind of findings fact sheet on our website at mmc.gov under, I think it's under our Arctic section.
Okay.
Yep. And
thank you, Vicky.
So, yeah.
Vicky, keep us posted when you have funding decisions and similar, or when you have those reports coming up. Let us know, and it's important that we keep up with all these activities.
Thank you.
That being said, and related to that, I want to encourage everybody to relate whatever research activities they are conducting in the Arctic by browsing the performance elements of these and other collaboration teams, and letting us know what's being accomplished and what's being achieved, so we can properly keep track of all these research activities. As a side note, I was very pleased a couple of months ago. I was reviewing an unnamed proposal where the authors were linking their proposed research to some of the IR performance elements. And that was very neat, I think. So that kind of connections we want to develop to not only make this Arctic research policy implementation more transparent, but also to hopefully generate this general awareness to foster collaboration and leverage resources for everyone. Are there any final comments or announcements or questions?
Guillermo, this is Danielle. I just wanted to let everyone know that the IRPIC team leaders are going to be having our annual workshop to make our plans for the coming year in June. It was supposed to be in February and we had to delay it. So it's coming up in June. So please share your ideas with us if you have things you'd like to see our webinars cover over the next 12 months.
Thank you, Danielle. Jackie, any final comments?
No, I think we will have another webinar in March, and we'll be developing that, and I'll provide information through this website.
Great. Thank you, everyone. We'll see each other at the March 27th call at the usual time, 2 p.m. Eastern Time, 10 a.m. Alaska time. Thank you.